Namaste, you all, and welcome back to this FreeRTOS series that we are covering on the ESP IDF platform using our ESP32 model. So, today we will be talking about hook. There are two types of hooks available in FreeRTOS. One is a tick hook, one is an idle hook. So, what are these hooks exactly? Consider them like a function which can be called at particular event. Let's say a tick hook is like an ISR or an interrupt routine, which is called after every tick interrupt. We have already covered what a tick is, and right now in our system, after every 10 millisecond, we get a tick interrupt. So this tick hook would be called after every 10 milliseconds. Then there is idle hook. So we have also talked about that we have idle task running on a particular CPU core, and when this idle task is running, additional stuffs can be done in this idle loop function. So idle loop function basically runs when the idle task is active. So what do we need to exactly do in order to activate these hooks? Let's head on to VS Code. Alright, so this is the progress that we have made till now. We have created tasks using extas create, extas static, and then we have used vtask delay until, and so this is where we are right now. Let me go to the terminal and open up menu config. So in this, last time we talked that you have to go to component config, FreeRTOS, kernel, and we saw config tick rate hertz last time. But this time we will talk about use idle loop and use tick loop. So here I have already enabled idle loop. Let me disable it. Again, enable it. Alright, so that is it. Also, let me enable tick loop. So I'll press S now to save this and hit enter. Let's now press escape. There we are. Now, let's talk about something crucial. So here, they have mentioned that in FreeRTOS, the tick hook and idle hook have some drawbacks. Let's study them one by one. The first is that the hooks are registered at compile time. Alright, that's because you have to basically call this application tick hook and application idle hook functions, and yes, that's at the compile time. And only one of each hook can be registered. So one idle hook and one tick hook. Then on multi-core targets, the FreeRTOS hooks are symmetric, which means that each of the core, which in our case, since we have ESP32 and it has two cores running, CPU 0, CPU 1, this means that there would be a common hook for tick interrupt and idle task of both cores. But that is for vanilla FreeRTOS. So what they have done in ESP-IDF, let's have a look at that. So ESP-IDF hooks have following features. That is, we can register as well as deregister it at runtime. How do we do that? Basically using this APIs. Then they are also claiming that multiple hooks can be registered with a maximum of 8 hooks of each type per core. So now you can have multiple hooks instead of just one for each kind of hook earlier, which is provided in the vanilla FreeRTOS. On multi-core targets, the hooks can be asymmetric now, meaning both the cores will have different hooks. So that's also a possibility. So for that, we have provided few APIs. They have a register FreeRTOS tick hook and register FreeRTOS tick hook for CPU. If you want this to be CPU specific, you can provide this as well. Then we have deregister, we have register idle hook and deregister idle hook. All right, let's start with implementing them. So for this, we need to include ESP FreeRTOS hook.h, or I think it was hooks. Yeah. Next, we will call this register function system in our app main. Let's have a look for ESP register for you. Now, let's have a look what it is called. This is ESP FreeRTOS idle CV, and this is a Boolean type. So we need to have a Boolean function. Now, what should we do? So here it's saying that this function registers a callback to the idle hook of the code that calls this function. This callback should return true if it should be called by the idle hook once per interrupt, and return false if it should be called repeatedly as fast as possible. What does this mean exactly? Basically, if in this Boolean function that I have created, if I do this false, this executes repeatedly. While if I do this true, this hook executes at every tick interrupt. You want to see it in real time? Let's create a counter and increment it here. Let's now call this particular hook, print in any of one of the tasks. Print it here. All right. Nope. We are missing something. What are we missing? Let me show you that. So they have stated the application must provide void v application tick hook void callback. Otherwise, this would throw an error. We need to provide empty application ID tick header. So we have provided an empty application header. Let us now go and build this. Okay, so I am facing an error in the build process, that is v application tick hook. Since I have enabled both in the menu config, let me add that as well. Okay, now let me build. So yeah, now it's done. Let me flash this code to my board as well as monitor. All right, let me hit pause and zoom in. So there is our idle counter starting from 0, then some value. Obviously, this is a very big value because it's running continuously. So let me go with return true and see if it indeed is called at every tick interrupt. Let me hit pause and zoom in. So here we are. So ticks for task A and B started at 1. For idle, it started at 0. Next up, we can see since B used delay until exactly 100 ticks apart. And when we can also see the idle counter at 100, 200, 300, 400. So yes, it does get activated at every tick interrupt. Cool. Let us now go on to tick hook. For tick hook, we have this function register FreeRTOS tick hook. So it's almost similar, but let's see what this needs. That is a void. All right. So this one registers a callback to be called from the calling code tick. Nothing to return. So we are done with the code for tick hook as well. Let's go and build this. Let me hit pause again and zoom in. So here we are, tick 1, task A and task B has tick 1 as well. Idle is at 0. Then tick 100, idle counter also, since it's activated at every tick interrupt, is also 100. Tick 200, idle 200, tick 300, idle 300. Okay, now that we know some basics about how to implement your idle and task hooks in ESP32 using the IDF, we should think like what's exactly the application of this tick hook and idle hook. Let's first talk about tick hook. So tick hook is like an ISR, like it routinely is called after every tick interrupt. Now suppose you want something to happen like a simple, I won't exactly code it right now, but let's say you just want a simple GPIO logic to take place at after specific counters, let's say after every 2000 milliseconds. So that means 200 tick counters, right? So you can do that, or anything else which needs a specific time period requirement. You don't need to clutter your task, but make sure that whatever you want to do is does not need much of a logic. It's simple. It just needs to be periodic, but it's simple. You don't need to create any extra timer. You don't need to clutter your task, but it should be simple as well. And remember not to use any blocking methods like vtask delay or any such things in tick hook or idle hook for that matter. All right. Now, why should we use idle hook? Well, first of all, it is used when you call vtask delete. We'll be covering that in later videos. Why is it called? To clear memory sectors or whatever resources they have used. So that could be one purpose. Then for lower priority management calls, it could be anything from a simple GPIO trigger after every few while, or you can be checking anything if your idle period is long. Right now, in our case, after every 1 second, this idle hook is called. But let's say you have logic, certain logic wherein your tasks are in block state for majority of the time during your code. You can even put your code in sleep using this idle hook. So after it's in sleep, it will consume less power, and then you can trigger something to wake it up back, and then again. So that's the basics about hooks. If you enjoyed this video, do not forget to like and share this. And also, if you haven't yet subscribed, do hit the subscribe button as well as the bell icon. This is Avinashee Tech signing off.